So let us now take question number 4. Okay, the question says, how many atoms of oxygen are there in 6 grams of calcium trioxocarbonate 4? How many atoms of oxygen? Now listen, look at what many students do. Many students will tell you CaCO3. When you ask them how many atoms of oxygen that this compound contains, they will tell you simple, the number of atoms of oxygen is 3 atoms of oxygen. Is wrong. When you put H2SO4 and they ask you how many atoms of oxygen will be present in this compound, student will tell you the atom of oxygen is 4 atoms of oxygen. Correct it in this class now, because it is wrong. This thing is not 3 atoms of oxygen. Call it 3 moles of atoms of oxygen. This is not 4 atoms of what? Oxygen that is here, but 4 moles of atoms of oxygen. So if you get that well, to calculate this question will be simpler for you. Okay, now this is what I will do. Do you know that 1 mole of CaCO3 will be equivalent to how many oxygen? 3. That is 3 moles of atom of oxygen. I hope you've understood what I mean. Don't say that one mole of this thing contains 3 atoms. No, but 3 moles of atoms of what? Oxygen. So if 1 mole of calcium carbonate or calcium trioxocarbonate 4 contains 3 moles of what? Atoms of oxygen. What is the mass of calcium trioxocarbonate 4? Because what they gave you here is mass and not what? Not mole. So you have to convert 1 mole of this to what? To mass, to start with. So what we do is what? 1 mole of calcium carbonate simply means 1 multiplied by calcium is 40 plus carbon 12 plus oxygen 16 times 3 gram. That is how you convert to gram. 1 times the molar mass of this will give you 3 moles of atoms of oxygen, right? If you calculate this, you get what? 100 grams of calcium carbonate, calcium trioxocarbonate 4 will give you 3 moles of atoms of oxygen. Now, having known that from 1 mole of this, which is 100 gram, is giving you 3 moles of atoms of oxygen, then the mass they gave you from the equation, how many moles of atoms of oxygen will it contain? So take it that 6 grams of what? Calcium carbonate will now contain X moles of what? Atoms of oxygen. Now find what X is. X here will become 6 times 3 divided by what? 100. So that will give us what? 1.8 moles of atoms of oxygen. So what does it mean? It simply means that what? If 100 grams of calcium carbonate, which is 1 mole, will give us 3 moles of atoms of oxygen, then 6 grams of that same calcium carbonate will give us what? 1.8 moles of atoms of oxygen. But if you look at this question, the question did not ask you to find how many moles of atom. It says how many atom. How many atom? How many atom is not the same thing as how many moles of atom. So we have gotten the what? The number of moles of atom of calcium carbonate that is present, okay, in this compound, and that is 1.8 moles of atom of what? Oxygen that this compound what? Contain. Now convert from moles of atom to what? To atom that the equation is talking about. So how do we do this? You go to the standard. What is the standard? 1 mole of any substance. Any substance. So 1 mole of atom of oxygen will contain the Avogadro's number of what? Atoms, which is 6.022 times 10 raised to 23 atoms. You can see it now. 1 mole of anything, be it 1 mole of electron, be it 1 mole of a molecule, be it 1 mole, okay, of any substance. 1 mole of any substance will give you this number of particles. So 1 mole of atom of oxygen will give us this number of atoms of oxygen. Then the one we calculated is 1.8 moles of atoms of oxygen. So by standard, if 1 mole of atom of oxygen will give us this number of atoms, then the one we got from our calculation, which is what? 1.8, which is 1.8 moles of atom of oxygen. What will it give us? How many atoms will it give us? Take it to the x. So we are now converting from moles of atom to what? To atom. So if we do the calculation, you will see that what? My x will be what? 1.8 times 10 times what? Times 6.022 times 10 raised to 23 atoms will be divided by what? By 1. This multiplied by this over 1. So what will be our final answer? Our x now will now become 1.1 times 10 raised to power 23 atoms of oxygen. So I want you students to be careful with this kind of question. When they ask you, when they give you mass and ask you to calculate the number of atoms for a compound, you have to find the number of moles of atoms before you now convert from mole of atom to ordinary atoms, which is the answer now. So that is the answer. So let us take question 5. Now, if you are enjoying this class or you like this class, please, I want you to subscribe. Okay, before we go on, subscribe to my channel, share and like my videos, recommend it, okay, to your friends. Now, when we look at this, you say how many atoms of oxygen are there in 20 grams of carbon 4 oxide? How many atoms of oxygen? So when we write CO2 and say how many atoms of oxygen is here, many students will tell me that the number of atoms here is 2. It's not 2 atoms. This is not 2 atoms of oxygen, but 2 moles of atoms of oxygen. That is the right way to go for you to get the answer for this what? Calculation, or to this calculation. Now what do we do? 1 mole of CO2 will contain 6.022 times 10 raised to power 23 atoms. Okay, sorry. Let me not relate because we have not gotten to that. 1 mole of CO2 will contain 2 moles of atoms of oxygen. That is good. 1 mole of this will contain 2 moles of atoms of oxygen. Remember that 1 mole of carbon 4 oxide is the molar mass of carbon 4 oxide. 12 plus 16 times 2, it will give you 44. So what it simply means is that what? 44 grams of carbon 4 oxide will give you 2 moles, or will contain 2 moles of atoms of oxygen. So if 44 grams of carbon dioxide contains 2 moles of atoms of oxygen, the mass they gave us for the equation, which is 20 grams of CO2, how many moles of atom will it contain? Take it to be x. So x becomes 20 here multiplied by 2 divided by what? By 44. When you divide, you will get 0.91. 0.91 what? Moles of atom of oxygen. Are we asked to calculate moles of atom of oxygen? No. We are told to calculate atom. How many what? Atoms. Not how many moles of atom. So it's not good for you to convert from mole to ordinary atom. That is moles of atom to atom. How do we convert from moles of atom of oxygen to ordinary atoms of oxygen? Know that what? 1 mole of atom of oxygen will always contain the Avogadro's number of atoms, because 1 mole of any substance will contain 6.2022 times 10 raised to power 23 atoms. That is what we contain. So if 1 mole of atom contain this, then this number of atoms we have calculated, which is what? 0.91 moles of atom of oxygen, will now give us to be what? X. So x becomes 0.91 times 10 raised to power 0.91 times 6.022 times 10 raised to power 23 atoms. Okay, so if we hit our calculator 5.48, x will be equals to what? X will be equals to 5.48 times 10 raised to power 23 atoms of oxygen. So we are converted from moles of atom to ordinary atom, and that is the answer. Now we are taking question 6. Says how many hydrogen ions are there in 40 grams of tetraoxosulfuric acid? How many hydrogen ions are there in this compound? Hydrogen ions, you need to ionize this what? Acid for you to calculate. Now you know that what? H2SO4 will ionize to give you 2H plus SO4 2 minus. What does it mean? Remember, this is 1 mole, right? And this is what? 2. 1, 2. So what does it mean? It means that 1 mole, that is 1 here. 1 mole of H2SO4 will give you 2 moles of hydrogen ion. It is not moles of hydrogen ion that we want to calculate. They say how many hydrogen ion? How many hydrogen ion? Not moles of hydrogen ion. Are we there now? So 1 mole of this acid will give you 2 moles of hydrogen ion. What is 1 mole of this acid? 1 mole of H2SO4 is the molar mass. 2 plus 32 plus 16 times 4. Everything will give us what? 98 grams of H2SO4. That is the molar mass. Will give us what? 2 moles of hydrogen ion. Now, if 98 grams give us 2 moles of hydrogen, okay, I can put hydrogen ion, that is H plus. Okay, then the amount given to us from the equation, which is 40 grams. So 40 grams of H2SO4. How many moles of hydrogen ion will it give us? Take it to the S. So our S will be equals to this times this, which is 40 times 2, okay, divided by 98. So if you make this calculation, okay, it will give you 0.82 moles of hydrogen ion. But if you look, it is not what moles of hydrogen ion that they say we should find. We are not asked to find moles of hydrogen ion. We are asked to find hydrogen ion. So we have to convert from moles of hydrogen ion to ordinary hydrogen ion. How do we do that? We know that 1 mole of any substance is the Avogadro's number of that particle. Okay? So what I mean is this: 1 mole of hydrogen ion will be equals to 6.022 times 10 raised to power 23 hydrogen ions. So hydrogen ion, we go with what? Hydrogen ion, not atom. Atom will go with atom. Molecule will go with molecule. Ion will go with what? Ion. Now, if 1 mole of hydrogen ion gives us this number of ions from our calculation, 0.82, okay, moles of hydrogen ion will now give us X hydrogen ion. Give us S hydrogen ion. Remember, we are looking for hydrogen ion. So having gotten this, we cross multiply to get our answer. So X will become 0.82 times 6.022 times 10 raised to power 23 hydrogen, okay, hydrogen ions. So our X is 4.94 times 10 raised to power 23 hydrogen ions. So that is our answer. Please subscribe to my channel, okay, share and like my videos. It will help you anytime I drop, okay, my videos, so that you'll be able to follow all the teachings and lessons, okay. This will help you prepare for exams like JAMB, NECO, WAEC, GCE, okay, SAT exam, okay, UN exam. So it is very vital for your examination, even first year. Thank you very much.